Hello, everyone. A very warm welcome to all of you. I So we will wait for a couple of more minutes before we get started, right? So that more people can join. And once we have more people with us, we'll get started with the session. All right. I'll be talking to you guys soon again. Hey, everyone. A very warm evening to all of you. Hope you all are doing great. Uh, Welcome to the session. And please acknowledge in the chat if you guys are able to hear me and see me. Am I audible and visible? All right, guys. So, just to warm up, I would like you all to, just quickly tell me. You all have, of course, registered for the hackathon. So, just share your team name and, probably which city are you hailing from. In case you guys are from multiple cities, just the leaders' city is fine for now. But yes, we're just getting a sense of if the chat is all good and we are ready to set rolling. Yeah. Perfect. Great. All right, guys. So thank you so much for engaging in the chat and good to see all the excitement. So we'll begin now. And yeah. So firstly, I would quickly like to set some context. You all have registered for the hackathon, and the idea for this particular session is to get you guys started quickly, right? We do have a lot of different tools, right? You know already that this hackathon needs to be done using what we call as OpenEnv, right? So to get you guys quickly started, especially if you've been struggling to get started and make it easy for you to perform step number one for the hackathon, we are setting up this particular session. And with me today, I have Ben, who's from Hugging Face. And Ben will be talking with you guys very soon. And he will be giving you guys a walkthrough of what reinforcement learning is. We are going to keep that very short, right? He'll set context for how the library OpenEnv makes it very easy and straightforward for you to develop your own environments, which is exactly what you need to do for this particular hackathon, right? So over to you, Ben, and let's quickly welcome Ben. And yes, over to you.
Thanks, Pulkit. Yes, so I'm looking forward to giving this talk. And basically the talk is really about how to build a real world env. So like really just how to win the hackathon could be the simplest way of putting it. And whenever anyone asks me this, my answer is pretty straightforward. It's that I think a good environment is one that I could imagine one of my post-training or reinforcement learning colleagues using in one of their training runs. So would they put this into their training run and use it because it represented a real world task? So if you take a product like Claude Code, Codex, an environment like Git would be a perfect environment to put into that product. Now, we already have environments for Git, so that's not something that you could win this hackathon with. But if you think about future products, maybe ones that operate over calendars and kind of email triage or other kind of use cases that we haven't really thought of yet, let's say in specific domains like healthcare, the environments that those products would need. So let's say if you had a kind of Claude Code for health, then what environment would that product need? That's the real takeaway of like what a good env is. Okay, something that really fits with a product and a use case. So to understand that, we have to first understand what RL is. So reinforcement learning. So we're going to go over a brief overview of reinforcement learning, and then we're going to go into the environment itself. So if you don't know, the project OpenEnv, sometimes called OpenEnv, but it's really OpenEnv, it's a short for environment. It is a collaboration between Meta, Torch, Hugging Face, and Unsloth. Because of that, I have some really nice slides from the Unsloth team, and they're going to walk us through reinforcement learning. So we're going to start off with just intuition, right? Let's say that we ask an LLM to write a fast matrix multiplication function. It could be any Python function, it could be a whole code base, but in this example, we're just saying generate a fast matrix multiplication function. We give it some formatting constraints. In this case, put the code between triple backticks. The model will produce an implementation, but this is just a single generation. What happens when we want to generate many of these? We can't call the model once, we call it many times to get different candidate implementations. Then we feed each one of those implementations to an RL environment where we verify and test it. For example, this could be a compiler, a unit test, a benchmark harness. It could be another LLM that judges the code. And the environment checks, does this code actually work? Is it fast? Does it follow the format, right? So we set the criteria, sometimes called rubrics, and the environment will judge based on that criteria and give back a reward. This is a score. So the first implementation that you see on the slide uses Torch MapMul. So it's correct and well formatted, so it gets a +10. The second uses NumPy, which isn't ideal because it's not fast, so it gets a -5. And the third one has a bug in it, so it gets -100. We really want to penalize the model that and tell it never to learn that. And it's this score that is at the heart of RL. So we need a valid signal telling us what's good and what's bad. So it doesn't really matter if you come up with the ultimate use case, you know, that kind of codex for healthcare or something that's nobody's ever thought of. If you can't frame that in the context of a reward signal and deliver that reward signal back to the model, then it's redundant. So it's really a balancing act between this high value domain and the ability to deliver that reward signal. So one approach is in-context learning, right? We can give the language model examples. We can take the scored outputs and inject them back into the prompt. So we're telling the model how to perform. We're turning the task into a few-shot one. This works, but there's a problem, a limitation from this. The process will create an ever-growing prompt. You accumulate thousands of examples or many examples, and the context fills up. So even models with million token context, like we're starting to see now, will degrade in performance. We know that models like Gemini, the latest Gemini model will degrade 20% on benchmarks that measure this, like needle in a haystack. So this isn't something that we can rely on, and ultimately it impacts the usability of that model because you're relying on context to maintain performance. And fundamentally, yeah, we're just burning tokens and we don't want to do this. So we need a more efficient way. And that's where RL comes in. So instead of putting all of these examples into a context, we assign the reward to every token in the output. And the good implementation is scored with say, a +10. And every token in that generation gets labeled. So we're going to use these labels to update the model's weights through backpropagation in relation to these tokens. And for the bad implementation, we're going to do the opposite. We're going to give every token a -100 or whatever the score of the environment gives. This is very crude, but it generally works. And the think tokens in this example were probably okay, for example. That wasn't necessarily a problem. So we probably want to come back and fix that up, but I'll get to that later. Okay, so we can reframe RL in a slightly different way. So we can say that patience is all you need. If we say that RL is just updating the weights with backpropagation and using reward signals instead of supervised labels, we don't need a long context, and we can be more context efficient with in-context learning. But the catch, the downside, is that this takes longer than supervised fine-tuning. At the start, the model will produce garbage and get 0 reward. So you have to wait, and eventually it finds something good, and the training takes off. If we give you an example in a kind of geometric setting, right, like just to kind of help your intuition to grow. At the start of training, the model's output distribution is roughly uniform. Every token has an equal likelihood. When the model produces these bad outputs, RL will penalize them, pushing their probability down. As those bad outputs get penalized, their probability drops, and the remaining probability mass redistributes across the landscape. So RL is systematically ruling out bad regions in that output space as tokens.
Hey Ben, sorry if I may interject here just for 1 minute, if that's okay. So you did mention about how it's different from supervised fine tuning, right? Could we maybe take a minute here to sort of talk about what sort of scenarios would be suitable for supervised fine tuning and where reinforcement learning based fine tuning would shine out? If you can maybe take a minute to point that out.
Okay. Yeah, that's a bit of a side note. I'm going to come back to supervised fine tuning and where it fits in a couple of slides. So
Okay.
I'll leave it till then because
Okay.
we're kind of in the middle of honing our intuition around how RL works. So let's kind of keep focused for a second, and then we'll go to RL.
Yeah. Thank you.
No worries. So okay, we've got this uniform distribution, right? And we've adapted the uniform distribution by penalizing certain tokens. And the model is going to maintain this now, is going to now learn about these tokens that it should penalize. At a certain point, the model stumbles upon a good answer. And the reinforcement learning will dramatically amplify this. The probability spikes up, and it will reshape the entire probability distribution. So this means that RL isn't dumb in simple terms. It's just not very efficient. And so because of this crude per token reward assignment. So this is a fundamental aspect of RL that we have to be aware of. And we have to build environments that give rich reward signals back to the language model, so that the probability of a good answer has to be greater than 0, and that learning landscape has to be as rich as possible. If the model literally can never produce a correct output, or it's very difficult to ever produce a correct output because, say, the task is too hard, the formatting is wrong, or it's too out of distribution for that model, yeah, it's too hard, something it's never seen before, RL won't work. So this is one of the things that we're really focusing on. Is this a task that a model can do? Is it formatted correctly? And how can I format this task differently? Could I give it a better prompt? Could I give the task more information, more tools? These kind of questions you'll ask yourself. Otherwise, you'll just waste compute. The model might never learn. And common failure modes are wrong formatting, no pre-training warm-up, and it's just too far from something the model is able to do. So that is where the earlier stages of the pipeline come in. And so this responds to Pulkit's question about supervised fine-tuning. So in practice, we need all of the stages of the pipeline. Pre-training gives the language model a general understanding of language, right? It's next token prediction. It allows it to pick up this general knowledge about how things work, how things relate to each other. And it's in supervised fine-tuning that the task is instruction tuned. So it will perform a certain task. It will learn to chat. It will learn to use tools and these kinds of things. It will learn to use tools correctly. So it will be given examples of good usages. And in general, we want to invest the majority of compute in this pre-training phase. And we want to invest another chunk of compute in the supervised fine-tuning phase, because that's where the model will learn the right format and to follow instructions. So if we're planning to use a language model for something like healthcare, we would want to make sure that there was relevant information about healthcare in its pre-training data. We could continue its pre-training data if necessary, its pre-training phase if necessary. And we would want to know that during the SST phase, that there was relevant instructions and tasks to its usage. And we could go quite close to the line, quite close to the task with just SFT. Let's say we had a specific task to use some healthcare tools. We could give examples to the model of how to use those tools as traces during SFT. And the RL could squeeze out the last gains on specific capabilities. Let's say another 5 to 10% on a benchmark, for example's sake. So let's imagine that this is the kind of journey that the models go on. They start with pre-training and they move all the way through SFT and then into RL. And so it might look something like this. And this is, you know, how you could imagine a modern training pipeline visually. So we start with the pre-training, we move to SFT, and then we move to RL. Now, you could ask, could you just skip SFT and go straight to RL from pre-training? Theoretically, yes. And there is a paper on this called DeepSeek Zero. But in practice, this is a very wasteful strategy. And the whole point of the pipeline is efficiency. So each stage should bootstrap the next stage. So we don't want to skip a stage like this and move straight to RL, even though it's technically possible. Another way to make RL more efficient is process supervision. So instead of giving every single token the same reward as I showed you at the beginning, you can assign different scores to different tokens. So in this example, you see that I've given the think tokens a 0 because they're not necessarily wrong. The model is thinking between it's generating reasoning tokens within the correct block. So you could say, okay, it's correct there. The real errors are down in the Python function. So we'll use that for reward. And this gives a much more informative learning landscape to the model. So we can take this further and we can develop these kind of rewards into our environment as well, and give these this more detailed process supervision. Another example of how we could do this is to use LLMs as judge. So we could say, is this line correct? Is this relevant to the original question? Is this a concise answer to the question? These kinds of things that we can't necessarily implement as a verifiable function in code. So a major topic then is reward hacking. So the model might learn to game the verifier. It could delete the timer in a benchmark, for example. I've seen that one myself quite often. When you're getting a model to generate, say, a kernel or an optimized piece of code, it will sometimes try to game the timing system within the code and find shortcuts to get around this. And yeah, there's this example about the Cobra effect, where in India in colonial times, they offered rewards for collecting dead cobras, and so people bred cobras and then brought the dead cobras in. It's this kind of archetypal example of reward hacking, maybe the original reward hack, but probably not. And when the bounty was cancelled, the people released all of the cobras, and it was significantly worse before. The model will give you exactly what you ask for, is the simple takeaway, which may not be what you wanted. In the worst case, the model should try to corrupt the testing environment itself. So it could overwrite files, it could modify its test harness, it could inject malicious code. And so this might not, in fact, impact the learning landscape, but it could impact safety or security. And so this is why we need sandboxing for RL training. So in practice, you catch reward hacking by sampling outputs every 10 to 100 steps for manual inspection, and use multiple independent reward functions, monitoring output for suspicious rewards, and having an untrained reference model as a judge rather than model judging itself. So the real takeaway from this is to look at the trajectories, look at the interactions between the model and the environment, and just give it a kind of smell test, right? Like just say, does this make sense, what it's doing here? And that will mostly help you to know whether reward hacking is taking place, but also whether your environment makes sense and whether the game or the task that it's fulfilling is a logical one, whether it's one that the model is actually able to achieve. Okay, so let's kind of level up a notch there and go to how this relates to the field. And so we'll start to look at some more RL projects. Before we go into the environment itself, let's talk about how LLMs are typically post-trained. So most models today are post-trained in multiple stages, as I mentioned, SST and RL. If you want to go deeper into this, I'd recommend the OLMO 3 tech report, because it's one of the most open source projects recently. It's from just last year, and they go really deep into this. So if you want much more information about the full life cycle of an LLM, go and check out the OLMO 3 tech report. What we also need to consider, though, is that when a model or an agent is deployed in the real world, things get very messy. So LLMs are used in all sorts of applications, right? From generating code to kind of booking flights and all these kind of examples. In typical RL training, the problem distribution is predetermined by a specific data set and remains static, preventing adaptation to the policy's model's evolving capabilities. And so models trained with this static single-turn data sets tend to be weak at correcting their own mistakes because their reward was derived from single-turn rollouts. In real life, models need to adapt to changing environments. Let's say they book a flight, but the flight is no longer available. They merge a branch, but there was another commit, these kinds of things. And so one of the real signals of a high-quality environment is how it maps a particularly long-running task. So that's something that I would strongly recommend in your project, and it will be rewarded within the hackathon. Long-running tasks with multiple trajectories, multiple routes through those environments. As I've said, environments can be anything. They can be web browsers, MCP servers, compilers, game engines. And a fascinating direction from the Chinese lab Kimi K2 was to create LLM simulated APIs where a language model pretends to be an external service and the agent learns to interact with these simulated tools. So you can think of environments as supersets of tools. If you teach models to use environments, they work better with real tools at inference time. So the idea here is that they're highly generalized environments that are generated interactively. So environments also solve the curricular problem. I mentioned earlier with the static data set, the problem difficulty is fixed at the beginning. With environment, you can dynamically generate problems matched to the model's current capability. So you can start off with easy problems and build up in complexity to harder problems. We could take a look at the RLVE paper that showed that training with over 400 verifiable environments significantly outperforms static RLVR, which is reinforcement learning from verifiable rewards, because the model always trains at the correct difficulty. That's a really interesting takeaway from that aspect. So as I mentioned earlier, if the model never achieves this reward, it never gets this signal, then we're wasting compute. So what we can do there is to introduce easier tasks at the beginning and build up the complexity of those tasks so that the model is constantly getting this reward. For the example of booking flights, let's say that in the first few turns of the environment, they're quite simple flight situations. Okay, the flight is available, there's definitely one to choose from, and it's given a reward for booking the correct flight. Later in the training phase, it might be given situations where there is no flight available and it needs to go back to the user to request more information, or there are multiple flights available, or there's no direct flight available, and so it has to use a transfer. These kind of complexities you can introduce as the process goes on. And one important thing to mention is that Frontier Labs are already scaling this aggressively. If we look at the DeepSeek V3.2 paper, it used nearly 2,000 distinct environments and 85,000 prompts. So this is a huge part of training frontier models now, is the takeaway. We can also look at the Minimax paper, which used over 100,000 environments extracted from real GitHub repositories. And each repo became an environment where the agent gets a task like fix this bug, and it navigates the code base, fixes issues, and runs a test. And so the testing suite in that was used as a reward signal. Okay, that's really cool. Those are some examples that you can go away and check out if you want to deep dive on this. But if you actually look around GitHub, you look around the ecosystem, what you'll find are a lot of RL environments in GitHub repos, very difficult to find and not compatible with each other. And it's kind of comparable to the early days of language models, actually. And before they were on the Hugging Face Hub, and before, when they were in kind of Google Drive, and they weren't necessarily compatible with the training frameworks, and they were difficult to use. So because of this, they're very difficult to scale. They might be quite hard to even set up as a single training run, but to get up to the thousands that Frontier Labs are using is almost impossible, or probably impossible. And that problem is what motivates OpenEnv. We want RL environments that are for everyone and that are compatible and have a single interface so that we can easily scale them. So OpenEnv takes a simple strategy where an agent interacts with an environment, the agent makes actions in the environment, it gets back observations from the environment and a reward. It uses a single API that's consistent across all environments, and it allows environments to be plugged into a training run en masse, and that training framework be able to handle those due to their interoperability. So here's a concrete example, not the kind that you could win this hackathon with, because in itself it is quite simple, and we're really looking for real world ones. But it's a nice educational example. So we trained a model to play the game Wordle using GRPO. If you check out the course, you'll also find the example for this if you want to follow along. The course being the one that's linked with the onboarding material. And in the Wordle environment, you define a rollout function of how to play the game and how to generate guesses and feed them to the game and extract rewards. You'll notice here that the game gives partial rewards. So in the game of Wordle, if you get a yellow letter, it means that that letter is correct, but it's not in the correct place. If you get a green letter, it means that it's the correct letter and it's in the correct place. So in this environment, when the model gets a yellow letter, it was given a 0.2. And when it gets a correct letter, it's given a 0.4, I think, off the top of my head. And so what this means is that as those very small models that we use in this training example of a 0.7 billion parameters, as they struggle to get correct guesses, they get a certain reward for guessing the correct letter. When we trained this, what we found was then the language model would start to predict the correct letter again and again and again, which wouldn't really make sense, because if a human got the correct letter, they would then think, okay, I need to now move it to the correct place. So they would move it. And it would just keep guessing, say one word, say crane, crane, crane. So we penalized the model for repeating the same guess. And that gave it more signal that it could use. And then it would stop repeating, and it would start to make new guesses. And once it made new guesses, it would move the correct letter around. And and it had a richer landscape. And we can see in this example that you have a valid reward signal. This is, as I said, a basic example. It's something worth trying out. It's not the kind of environment you could submit to this hackathon, but it's definitely a great educational one. As I mentioned, but maybe it's worth iterating, OpenEnv is framework agnostic. So the example I showed works in TRL. There's also unsloth examples in the main GitHub repo, but it works in other libraries like Agent Reinforcement Trainer, Lightning AI's library. It works in UMI and others. And the environment spec is the contract. So you don't need to set up integrations with any library, right? You can just define the environment and plug it into that training framework. So let's take a look at how it works, right? I'm in a second going to go over to Hugging Face and show you what it looks like there. But for now, I'm just going to show you it on these slides. So every environment is a Python package. I'll show you how we make that in a second. But what that means is that we can install the Python package with pip from Hugging Face. So we can say pip install the Python package, and we'll get the client code. And as you can see here, we can say env equals myenv, and then we can pull it from the hub as a Docker image, or we can interact with it with the hub running there. So that's why the space is quite convenient. We get both the server, the container, and the client code all in one place. And this is what it looks like on Hugging Face. You might have seen this already. They're small apps, and they're based as spaces. So they're deployed with a UI and an API. They're also a Git repository, which means they're version controlled and you can install them, as I said. They have authentication, so you can have a private end. They've also got a Docker registry, so you can pull it, as you saw. And all of this is wrapped into the OpenEnv CLI. So in order to create an env, you can just do OpenEnv init, give it a name, and then OpenEnv push, and it's deployed to the hub. Okay, let's go one level down and talk about how we implement the env. So I'm going to walk through what the skeleton contains. So there are 5 files, 5 steps, which you define in models.py. So that will be the action, the observation, and the state, which are as pedantic objects. The second is to implement your environment with a reset step and state. The fourth is to create the HTTP client. And then to wrap that in Fast API. And the final is to Dockerize it. In reality, all of this happens with OpenEnv init. So you don't need to go into these details, but these are the 5 components that bring the env together. When you do OpenEnv init, you'll get all of this out of the box. And so here's how the full pattern would work with something like Connect4. Your action data class is a column in the game Connect4. Your observation is the board and the legal actions and done. So let's say the rules. And the state tracks the board and the next player and any player moves. These pedantic objects extend the base OpenEnv types, so you're able to use those from the core library, and they get packaged into a Docker file. The server will expose a reset step, state, and health endpoints, which are all necessary for it to work. And here's an example, another example with a GPU kernel sandbox. So on reset, it detects the GPU model that we're working. It runs a baseline, records the baseline, and then on step, it receives some kernel code, some code to be optimized, compiles it, and then runs the benchmark, measures its performance, and returns back the reward. So the code for this kernel example follows the same pattern as Connect4. You have a kernel action, kernel code, etc., and it works through that. So what you'll see in your environment is the same API naming structure with action, observation, etc., but wrapped around your task. I'll show you that in a second. So that's basically the end of the slide. The one thing I'd say is to check out the GitHub repo, especially if you want to take it to the next level. We have other features in there like an MCP interface and rubrics for supporting LLM as a judge. So I'd go and try those out. Now I'm going to show you in the IDE what this looks like. And I'm kind of open to any questions as I transition across. Cool. So what you'll see here is just an empty directory, basically, an empty folder. And I've got a Python environment. So I'm going to install OpenEnv. The OpenEnv library is called OpenEnv Core. And it has a group for the CLI. I have to wrap that quotations. And we can do this. So it was already installed in my environment. And so what I can do here, this is a bit of a trick. If you want to use an agent for this, you can install skills with the CLI. So you can do OpenEnv skills add and say I'll do codec as a parameter, and then it's created a symlink. I'll come back to that in a second when I show you how to use an agent. But if I want to create an environment of my own, I can do OpenEnv init kernel env. So I'm giving the env a name. So I'm going to create a kernel optimization environment. So I say OpenEnv init kernel env. And what you'll see here is that the CLI replies, it created 11 files, generated a UV lock, and it created the environment. I can take a look in that directory, and you'll see that I get a server with an application file in it, manages the imports for me, sets up just a function that runs a Uvicorn server. Inside this directory, inside this file, sorry, it will then create my environment. And it's used a template and dropped my name into it, right? So all the way through, you'll see all of this pre-set up. And in fact, you could use this environment. It's very simple. It just rewards based on the length of the message. So you can't really train anything meaningful, but it is a working environment out of the box. And so that makes building much easier. You'll also notice that there's client code there and the models to define the action. So in this case, the message and the observation back is the echoed message and the message length. You'll notice that there's a openenv.yaml, which is where we configure how it works. It has a PyProject toml. So the environment itself is a managed Python project. And you'll see that all of the dependencies are installed there, but you'll need to add your own dependencies depending on the project that you use. If you use Python dependencies, that's fine. You can just put them all in here. If you have any non-Python dependencies, you'll need to use the Docker file. And that you can do here in the Docker file in the server. Now, as I mentioned, you'll also need to you'll also be able to use a coding agent to do this. So let's take a look at that. I'm going to now delete my env I just created from the template. And I'm going to open codecs. And I'm just going to reference the skills to double check that it's there. Yeah, so there it is. I've got this OpenEnv skill. So I'm just going to tell it to use it to make sure it does. And I'm going to say, create an environment for benchmarking kernels. Let's give it some more information. Let's say PyTorch kernels. Make sure it knows it's an RL environment. Cool. It should know that it's OpenEnv. Let's take a risk and not tell it to use OpenEnv. Okay, and now that's going to get to work. And while it's doing that, I'm going to show you how the skills are packaged. So what you'll see here is that it uses a skill.md, and it's all referenced in here. And so it has an instruction of how to use the same CLI that we used there. Great. So it's quite simple. We can also go and check the repository online to show you what it looks like. So if I now show you an example of an environment on the hub, and that will finish up. So if you take a look on Hugging Face and you go to Spaces, you'll notice that there's a filter here called Agent Environment. If you go there, you'll get a series of around 900, almost 1,000 RL environments that you can be inspired by. They use different libraries. You can also filter it so it's just OpenEnv. And so that's what you'll see here. And these are all implemented in OpenEnv. Or you can go to the OpenEnv org here, and you'll get a list of the envs that we're supporting. So let's take a look in there at some of the, if you see there's a collection here, got a number of environments there. And what you'll see is that this is an environment on Hugging Face, which is a space on Hugging Face. And when it's deployed, it comes with its own standard template that tells people how to use it. That's all packaged in, and a basic interface of how to use it manually to test that it works. You can also add a custom interface to the Gradio install, and that's listed within the documentation. So it's quite simple. It's just an extension to the default UI that is specific to that game. And that just helps people to use it. Like if there's quite a complex environment that you need to debug, like Wordle or anything else, you can use Gradio to create these custom UI components. I'd recommend doing that if you want to build a high quality env. And so that really concludes it. Let's see how Codex got on. So it wasn't able to finish in time. It's still working. But what you'll see here is that Codex is conforming to the correct, in fact it is, great, so it's already here. And what you'll see is that Codex is conforming to the standard because we've given it the skill that it needs to work from. So, sorry, I'm not sharing the correct screen. So Codex is still working here, using the skill to generate the environment that I showed you just now. And if we take a look in that environment, we'll see that it's no longer just a skeleton. It's actually a working PyTorch environment, working kernel bench environment that measures the performance of a kernel. Now it's generated by an agent, so it could very well be errors in here, but compared to examples where agents don't use skills, we found this to be a huge leg up. So if you're using any agent, Cursor, Codex, Claude, OpenCode, I would definitely suggest that you install the built-in skills from the library, and they'll tell the agent how to build an OpenEnv environment, and mainly tell it to use the CLI to start off from, and that gives it the API contract to begin with. Okay, so that concludes my contribution. I've got some time for any questions that jump in, if Pulkit wants to share them, but I'll mainly hand over to Pulkit now.
Hey, let me just check. Okay, all right. So, firstly, thank you so much, Ben, for that uh, walkthrough, for that introduction. I think that was super helpful for the hackathon. So, what I'm going to do now, firstly, we'll just take a look if there are any questions for Ben that we can share. And if not, I'll now give a walkthrough of a sample submission that you can do after going to the hackathon page. So that's one of the things that we want you to walk away with after this particular session. So yeah, let's just quickly see if there's anything.
So one question here that I think is quite important is, why is the inference script mandatory? That's a very important question. And the reason that it's mandatory is that that's how we will evaluate the environment. So I mentioned that at the beginning. If a model is never able to get a reward on an environment, then that environment it is basically useless to that training process, right? Like, we need to have a balance between something that is valuable and something that is feasible. So we'll use the inference script to measure how valuable that environment is. Can you share the skills link, please? There is no link. So if you use the OpenEnv CLI, you'll just use the command OpenEnv skills add, and it will add those skills to the directory you're working in. Check out the OpenEnv documentation for that. There's a page on how to add skills, or just do OpenEnv help in the CLI, and you'll see a command for doing that. Okay. So one question is, does the GUI development support 3D environments? It really supports anything because it uses Gradio. So Gradio has components for kind of anything you could really imagine. There's a HTML component, which is obviously very generic, and you can use JavaScript in there. There's a video component and other components. So Gradio is extremely extensible, and you can add any of those modules into the Gradio application. Okay, I'm really focusing on questions that are more about OpenEnv, but I can see that there are some questions about the hackathon itself. Okay, I think that's most of. So we need to integrate an OpenAI API into our environment. No, that would not be into the environment. You would use the OpenAI API within the inference script, and the environment would not have any mention of that at all, unless you were using a judge within the environment, for example. Okay, one question is, so we can't use any other agent other than Codex? No, that's not true. You can use any agent you want to generate environments, but you do need to use the OpenAI API in the inference script, because that's a standard, and we can easily swap that with different inference providers. Cool. I think that's a nice set of questions there. I'll be around in the Discord as well. If there are any there, definitely check out the Discord, and I'd go to the GitHub repo and check out everything there and give it a star. Cool, that's everything from me.
Thank you so much for that, Ben, again. I think everybody really appreciated having you on and giving a walkthrough of the entire ecosystem, as well as how Hugging Space helps in doing the deployment of the model. And yeah, thanks for taking up that question on inference. That was super important. I'm going to sort of highlight the same thing now. But yeah, so what I'm going to do now, just to keep things very simple, let me firstly take over the screen, if that's okay, Ben. And I'll take you all back to the page. So this is what we are going to do now in the next part of today's live. Let me first share my screen. All right. I think my screen should be visible. If I can quickly check with the team. Team, is my screen visible on the live? Perfect. All right. Okay. So once you register for the hackathon, this is the page you land upon, right? And over here, it's a specification for everything that needs to be done and how the task essentially needs to be completed. What we want to make sure is your uh, first first step for round one is well in place, right? That's what we want to ensure, and how we can help you out with that. So Ben has given you a walkthrough of the entire thing, how the environment needs to be built and how it needs to be deployed. What I'm going to do, I'm going to take a very, very simple echo environment, right? Just to keep things very simple, because that's something that goes with the inference script that we have provided. So one of the challenges that we believe is how do you essentially use the inference script? So to ensure that you're able to use it, on the dashboard itself, you should be able to see the inference script over here, right? So that's what essentially you can copy and put it in your project. And that's what you will be deploying. And that's how we will be assessing your environment. That's the whole idea. Okay. I'll give you a walkthrough of this inference script as well, but let's start. Let's sort of give you a quick recap of everything that Ben sort of said, right? Just a quick, very quick recap, not in terms of the theory, but in terms of how practically you accomplish this task, right? So starting from the setting up of the CLI, you have to do that, and then moving towards creating a very, very simple environments, an environment that gets set up straight away after you do your OpenEnv init command, right? So make sure all of those things are well set up. You also need Docker running in your local, right? That's how you will be able to proceed with all the different steps that need to be taken to make sure this runs smoothly. Okay. Another thing that you need to do is, because the deployments are happening on Hugging Face Hub, right? So make sure you have a token that you have created for yourself, right? If I may check with people in the live very quickly, have you guys generated your Hugging Face token? Are you guys all set with the Hugging Face token? Okay, in case not, so once you log in, you have to just giving a quick walkthrough, right? So just go to the access tokens, and over here you can go ahead and create a new token, and that should do it, right? And just make sure you are keeping it safe somewhere, because once you lose it, then you'll have to just create it again, right? It'll be available for you to see only once. Okay, so once this is done, right? Once this is done, we come back, and let's quickly proceed through all the different steps that need to be performed, right? So let me share the different screen now. All right, so some sanity checks just once you're on the terminal. Just make sure that things are working fine. Your open is set up. Those things are something that we need to make sure of, right? So wherever you plan to create your project, just what I would highly recommend is build a virtual environment and try to do things within the virtual environment, right? Once you're done with the installation of OpenEnv, right? So you have your pip install, right? Pip install of OpenEnv core, right? Once that gets done, then your library would be set. You can quickly check if everything's working fine by entering your Python, right? So just try importing the library. Okay, so this gives you a signal that everything's set. And once this is done, your CLI should work absolutely fine. So to quickly do an OpenEnv in it, you just need to create some environment where you will be setting up your project. So let's say just RL demo. Any name is fine, right? I'm just doing this to um, make you guys sort of be familiar with this, zooming in a little bit more. And once you do this, okay, so this is a signal that everything's worked fine. And while that happens, you should see over here, it also highlights all the steps that need to be performed post this to ensure everything is working fine, right? So now, just to give you a quick scan of what happens once you do this, what it does is it ensures all the files are set the way they should be. Okay. Now, one of the ways to show you if everything's working fine. By the way, we have shared this link on the live. You guys must have received it. Okay, sharing a different screen. Just give me a second. Okay, so over here, if you sort of go into by OpenEnv, like just into the intro part, it shows you how the entire thing is organized and what are the some of the things we need to be aware of. So firstly, you should be able to see over here that this is how, so as I created my environment, now the great thing is that all of these things get automatically created, right? Everything gets created automatically. And one thing you need to do is make sure you move this Docker file outside, right? It should not be inside server, just move it outside within the main folder. That's one of the things that would be important to do. Okay. And the other thing is this models.py is the file within which all your functions are going to reside, right? So basically everything that's connected to your reinforcement learning loop. Okay, all of those definitions are going to reside within models, and that's where you can go ahead, start doing the updates and start updating your environment. So to give you a walkthrough now, I'll take you to my VS Code, and over there I'll give you the walkthrough. But this is essentially what you'll observe once a project gets created. So let me share that again. Right, you should be able to see my environment now. So yeah, so this is a project that I've created, and once this is done, you should see all the files well within it. So as you can see from here, from server, I've moved the Docker file outside. That's very important thing to do. Another thing that you can do, if you remember from Ben's presentation, there was a clean web interface that we were able to see. To ensure that you are also able to see that web interface, one of the things that I recommend you guys to do is to put in this line, right, which is env enable web interface equal to true. So this way, when you call the API, right, you will be able to see this interface, and that just makes things easy. You know that everything's running fine, and you can even do some small experiments over there, right? Now, again, highlighting very quickly, if you go to the page, if you go to the dashboard, it's very clearly stating that you have to create real environments, not toy environments. The only reason why I'm showing you right now everything with the toy environment, with the echo environment, simply is so that you are clear with the relation between the inference script that you need as well as the environment that you create, because you'll have to update the inference script accordingly. Okay, but right now I just want to make sure that you understand the connection and it's all running smoothly. Okay, that's all we are trying to check right now. Okay, great. So now, once we have once we have added this line to the Docker file, and circling back just to give you a walkthrough of that models.py as I was mentioning, right? So this is what your init command does. It automatically initializes everything, right? It makes things super easy. So you can see over here that all the different things that you do in your reinforcement learning loop or the iteration, they're present over here, right? So this is the action and this is the observation. So both these things are present and it has created it for you. So this is what you need to update while you're creating your environment. This is where you go and make the changes. This is a super simple environment called as Echo. Right now, I'm going to keep it as it is because I want to make sure you're able to understand how everything's working. But yes, uh, at the risk of being too repetitive, I just want to call out again, no toy environments. For experiment, it's fine, but you have to go ahead and work with real environments. Okay, great. Now, and also towards the end, I will share some links with all of you of some real environment so that it gets easier for you to work with this. All right. Now, once we are done over here, once you have made the necessary changes in the model file, and you can sort of now start running everything right in the terminal itself. So pull up a terminal and start executing all the commands that were mentioned when you ran your init open init, right? So let me share a broader screen so that you can see multiple things at the same time. Just give me a second. Okay. So if I take you back to the terminal, you can see over here we have all these commands, right, for creating a Docker. Now just make sure your Docker is running, and then we start with the Docker build, right? So now you have to make sure that everything aligns with the name of the environment that you have created. That's super important. So I'm going to do the same. I'm going to make sure it aligns with my environment, and also ensure that you're using you also have UV installed. That just makes everything smooth and simple. If you remember from Ben's presentation as well, he used uh, the UV to run everything, right? Even the inference file. So coming back, yeah. Um, so firstly, again, pip3 install UV. For me, it's already done, but you make sure that this step is performed. Once this is done, we are now ready for the Docker build. So you go to Docker build. Okay. Oh, once again, I think my screen share stopped. Yeah, just a second. Right, you should be able to see my screen now. Yeah, so we are basically running the Docker build command. Okay, so we'll say Docker build. And this is the same command that gets generated for you. Make sure you're naming it as per your environment name. That's very, very important. Okay. So this should create the Docker. Okay. All right. So once this step is done, once the Docker is created, now we'll go ahead and sort of create the web server, right? So we'll launch the server. So we'll go ahead and run it. So Docker run. Right. Make sure you're writing the name of your environment correctly. So I'll just copy from here to make sure there's no mistake. Yeah. And let's hit enter. Yeah, okay. So this is a common error that you might get if you're running things multiple times, right? So this is basically happening because for me, the Docker is already running. So I just have to make sure that I shut that one down. Let me quickly do that. Just give me 1 second. Okay, let's try it again. All right, works fine this time. Let's go ahead and launch it. Okay, let me share the other screen now in the browser. Okay, so if everything's running fine, you should be able to see this, right? And sort of to again make sure that you're clear with this, that there are these three essential steps that you need to be clear with: the step, the reset, and the get state, right? These are the three things that we need to be familiar with. And for each of these, you can essentially this interface which you get at /web, right? So essentially when you launch it, you'll be on this particular screen, but then you can go to the web and just open it. And once you're here, you can just uh, plug in a simple message, because the purpose here is just to check if it's echoing back, right? So if I just say hello, click on step, and you should be able to get some output over here. And you can see, depending upon how everything's been defined, we are getting some reward, right? So this is how your entire thing should work. Okay, great. Coming back to Visual Studio and sort of now tying it with the inference script, because that's very important. So let's quickly do that. Okay, so now taking you to the inference script, just to sort of make sure you're clear with it. This is an important step that we all need to align with, because even if everything's working fine, you might face trouble with your submission unless the inference script is present. So quickly calling out few important steps. Make sure the Docker file is in the outermost folder, right? Don't let it be within server. Okay, that's point number one. Point number two, you also have to create this inference script. Now, this inference script is coming from the dashboard. Okay, I have simply copy pasted it. Exact script is going to work over here simply because it's associated with the echo environment, echo demo environment that we are creating. Okay, but if you're making changes, you'll of course have to make changes to the inference script as well. Now here, what I recommend is, because this script essentially is the format in which the submission needs to happen for whatever real world environments you create. You feel free to use AI to help you to configure this inference script and make changes to it accordingly, right? So just provide your entire environment, whatever changes you do to the model file, whatever changes you do to the environment file, and accordingly you ask AI to update your inference script as well. But to ensure that you have everything in place, make sure you're reading through all these steps over here, right? Make sure you're reading through all these steps. Okay, one more thing, by the way, your OpenEnv validate command should also work if everything is in the right place, right? So just like we have the init command, we also have the validate command. So once you have everything in place, run validate to make sure it's all running fine. Okay, and yeah. So now over here, there are a couple of things that you need to make sure are in place, right? If I sort of take you down, you will see over here we are doing some initial setup. So make sure you have everything aligned over here in terms of your Docker image name, right? So all those things need to be provided over here, the image name. The API key is essentially the Hugging Face token that I sort of showed you just some time back. Okay, this is again super important. Um, uh, Over here, you can see I've created this .env file where I'm sort of putting everything. All my environment variables are going into this one. Okay. Now, yeah, once this is done, you specify the model as well. Also, make sure of a few more things, right? You do provide the name of the model and update it over here if you're using a different model, right? Also, another thing, if you notice on the dashboard, it's mentioned over there that it's the open AI function that you really need to be using for this particular submission. So make sure you're not messing with that part as well. Make sure it's in the right place. And once you're taking care of all those things, then it should all run fine, right? That's the idea. Like, you can also test your inference script. So that's what I'm going to do next. But after giving you a quick walkthrough of this entire script, like what we are doing and how you will go ahead and make the necessary changes, right? So this inference script is sort of running that inference loop for you, right? All the different steps that you're supposed to perform, it's doing it for you. We are creating a prompt. The library that we have used over here, the extra library, is just simplifying for us how to create this system prompt that we are passing. That's the entire purpose of this. Okay. And just make sure of one more thing, right? Just make sure you have the you're executing the script towards the end, right? This is again a place where if things are not in the right place, you might face some issues, right? Okay, so let's go ahead and run the script, run the inference file, just to make sure everything's running fine, right? That's the final thing we'll do. I'll just open a new terminal for that. Okay. Just allow me a second. So we run. Sorry, just a second. Okay, let's quickly resolve this. Give me a second. Okay, so there are a bunch of steps that have to be done before we go ahead with this, right? One, we quickly set up a virtual environment within which we execute all of these steps, right? So let's quickly do that. It's like a full-on initialization of everything one by one. Okay. I think the screen share stopped. Let me do that again. Okay. I hope the screen is visible now. Are you all able to see the screen now? Yeah. Okay. All right. Okay, so let's just make sure we are running all the steps one by one, and it's a full initialization of everything. So okay, let's activate our virtual environment that we have just built. Yeah. So once you are inside the virtual environment, we now make sure that some of the things that we need to be able to execute this are installed. So we'll do a quick installation of the UV. Okay. Let me make sure everything's clearly visible. Yeah, okay. All right, so once the installation of UV is done, we go ahead and do UV sync. Next, we make sure our environment variables are in place. And finally, we go ahead and launch the inference file. Let's take a look at that. All right. Okay, you can see over here, the steps have started, right? This is a confirmation that everything's running fine. All right. So once you're at this point, that's an indication that your inference script is in sync with everything. It's all running fine, and now you're good to go with your submission, right? So that's the final thing. When Ben covered his presentation, I hope you do remember that all of this needs to be pushed to Hugging Face, right? Hugging Face spaces. That's where it all goes, and then finally you share the link of that. So just to give you a quick walkthrough of the final submission steps once, right? Let me take you to that page. Right, let me share a different screen, take you back to the browser. Yeah. All right. So this is the script that we use now, just to give you a final walkthrough of all the steps, right? So for this module 4, this is the walkthrough that we give. By the way, for each of these steps that you see, what Ben and I have done now, sort of, let's say if there are some things that you're unable to connect, you feel you need a recap of things, within each of these modules we have videos embedded which are sort of a walkthrough of these steps, right? So all the steps that we have taken, and the focus point of step 1 of the submission is building up our own environment. So what I just gave you a walkthrough of, you'll find that over here, and you will find it with respect to the Wordle environment. Now I gave you a very simple walkthrough, right? I gave you a walkthrough of your echo environment. We kept it super simple, but to show you the kind of complexity that you can look into while building these up, I'll take you back to the course. We have all shared this link of this OpenEnv course that the OpenEnv team has created. I'm talking about this particular course. And over here, if you sort of go to module 4, right? If I show you the notebook in the module 4, you'll see it is with respect to the Wordle example that Ben talked about. So that just shows you how you can create something more complicated, right? So uh, keep taking tiny steps. You take the first step, make sure echo runs smooth. But again, please remember that's just a toy example. That submission won't count. That's not a good enough submission. Then you can look into some examples that are way more powerful. Let me do one thing. Let me also share with you uh, a couple of links that will sort of show you what are the things that you can do with this. So let me share a couple of links with you guys. The kind of environments that people are building. Now, again, please keep in mind we do have plagiarism checks, so uh, do not entertain the idea of reusing any of this work. You have to create your own environments along with the inference script. But just to get a sense of the environment itself, some more examples for you. Ben has already shown you some examples on the Hugging Face OpenEnv space itself, but I'll give you a few more. So, team, if we could share it on the live, that would be great. Just sending it out. Just give me a second. Okay, so you'll be receiving the link soon on the live itself on the chat. Okay, now, yeah, as I said, you can go over this particular module to see how the environments need to be built. You'll see over here how the different classes are being modified, right? Especially for a task or for an environment that you are trying to create. So make sure you uh, go through this, right? Now, coming back to the hackathon page. So once you go through these courses, they will help you with a quick recap of everything. Then, okay, as a final piece, just remember this part. This is super important. Once you are done testing locally, this is what we did, right? We did UV runs inference.py. That gave us an indication that everything's running fine. And once you're ready to go, you have to do this OpenEnv push. Now, if OpenEnv is working fine, if you were able to do in it, you should be able to do the push part as well. And doing this will help you to push your environment to the Hugging Face space, right? So all you need to do is put in your Hugging Face username and the name of the environment, and that would do the job. After that, if you go back to Hugging Face, you will be able to see that environment deployed. And then the final step is to be able to share the URL of that space over here, and that would be all, right? I think that is all from my side, and we will take questions now. All right, guys, just allow us a couple of minutes. We are accumulating the questions so that we can start addressing them. And also, just making sure if we have covered everything that we wanted to, so that you guys walk away from here with some confidence, with some idea of how to make these submissions. You still have the time, right? The deadline is, you still have a good week for the deadline. Okay. Okay, so once again, highlighting the fact that this script is what will enable the evaluation for us, right? Without this script, the evaluation won't work. Okay. And this is exactly the script that I executed, but you will have to, of course, make changes to it depending upon your tasks, right? You can see over here, this is where we are configuring the rewards, and this is what is validating how well is your RL environment working. So make sure you are updating this as per the environment that you built. Okay. Cool. Just make sure you are following through all the mandatory steps, and don't miss out anything. You can see over here the mandatory steps have been called out. So make sure they're all in place. Without this, things might not work. Okay, especially when it comes to your submission. While you might feel things are working fine in the local, but without this, the inference at our end, when we are validating your script and when we are validating your submission, we won't be able to do it without these mandatory steps. So just make sure you're following through all these mandatory steps. All right. Okay, perfect. Maybe let's take a look at the questions, whatever are there, and try to sort of uh, answer. Okay. Okay, I think this one is an important question around the API itself, right? So make sure you're using the Hugging Face token. You don't have to pay for the OpenAI token. Do not create the OpenAI token. Again, I want to quickly highlight one thing. If I take you back to the script once, okay, I think the script page is already shared. So if I show this part to you quickly, you can see over here, right? When we are mentioning about the API key, we are basically loading it from the HF token. So that's the idea. Even if you do not have OpenAI token, and we do understand that's paid, so you don't have to worry about it. Uh, from Hugging Face, the token that you get some free credits, and that should be good enough for you to experiment with it and make your validate everything and make your submission. Right. Let's see what other questions do we have. Yeah. And the other thing would be over here for the API based URL, use the router. The idea is as follows that what this essentially does within Hugging Face, um, all the different large language model providers are available, right? So that's why we are not expecting you to call these externally. OpenAI, Claude, all these environments are available. So just use the router and use the Hugging Face token. It will automatically take care of things on your behalf. You don't have to worry about anything. Okay, cool. All right, we have. If I see the questions, as I said, we have already called out that you don't need to use the OpenAI key. You can use the Hugging Face token. That would be good enough. Yes, I think Prabhan RK has called this out well. That FCF router is a auto select model feature, and that would take care of calling the models, so you don't have to worry about it. Okay. Okay. As far as the selection of model goes, again, feel free to use whatever you want. In this particular example, we used Quen 72 billion instruct, but you are welcome to use something else as well. Okay. All right. To quickly recall, so I do see some questions around the perspective of overall wider perspective of the hackathon. So guys, focus on task one, which is to be able to create our own environment. See, understand, in reinforcement learning, what you do is as good as the environment you have. And the idea for OpenEnv package is to be able to give you the opportunity to create environments as per your expectation, right? For the link that we have shared with you earlier, you would be able to notice that there are some very complex environments that people have created. And the idea is we want you to be able to create your own environments. Okay. Later on will come. So once you're into the stage two, then we will start talking about things around how do you essentially execute everything. But right now the focus is build an environment, build an inference script for that environment, right? That's what the focus is for this particular round. Okay. Yes, absolutely. Feel free to use AI to your advantage, right? Especially for updating the inference script, right? The inference script that we have is for the Echo dummy project. But when you build your own environment, you would have to update it, and feel free to use AI to make that happen. Okay. This is something that we have tried at our end, and it does a fairly good job at updating as per your environment file, model file that you have created. It does a pretty good job at updating the inference script. Yeah, so on the topic end, right? Somebody said the inference script should be associated with some topic, right? So that's a very legit question. Please understand the environment you're building is itself the topic. Okay, so let me clarify with a simple example. Okay, think in terms of, let's say, a number guessing game, right? Now, when we talk about a number guessing game, so please hear me out for a couple of minutes. Okay, if we talk about a number guessing game, the idea is for your large language model to be able to play that game well, right? And based on that, we want to reward it or negatively give it negative marking if it does not do the right step. And the idea is the game is as follows: that you have to guess a number between, let's say, 1 and 100, and you have to ensure that it is able to guess the number within 10 steps, right? Let's keep it simple. So now you can actually build this environment, you can create this environment, right? And once the environment is created, then you can create an inference script to test how well the environment is working. So when we talk about test, this part is not linked to getting a high accuracy. It is simply to check if it is working well as per the grading scheme that you have created, right? You have to ensure that the grading scheme is for giving a marking between 0 and 1, right? And you can create your rewards as per the requirement of your task. So the idea is, now just think about it, right? What would you want? You would want this model to essentially be able to learn to do something that quickly comes up with the guess, right? So if it's just guessing randomly, it's going to be very challenging to find the number. But if it is able to build a strategy, it should be able to do it. But we are not worried about those things, at least in this particular step, right? In the first stage, we are simply concerned about you being able to think of a problem, out of the box problem, and then be able to create the environment for that problem. That's the focus point, right? Okay, so for all the questions pertaining to the ability to use other models, I just want to clarify one thing: just make sure whatever you use it through the HF router. That's super important, right? Because that's the token that you're using, and because your model ultimately gets, it's all connected to Hugging Face. So just ensure that whatever model you use is a model that's available within Hugging Face. That's the only constraint. But otherwise, within that environment, you're free to use whatever model you want to choose. Yeah, sure. Let me share the example that I just mentioned, right? So for the number guessing game, for example, like I was talking about creating it on our own, but that is present, by the way, as an environment already in Hugging Face spaces, right? Somebody has already created it, so you can very well use that. Okay. So for the grader should return a value between 0 and 1. That's the whole point, right? You can see over here. Okay, team, can you share back my screen? I think, yeah, okay, perfect. Yeah. So if you are able to see my screen, you should see this part, right? The grader should return a value between 0 and 1. That's the whole point, okay? So your reward system should be created accordingly. Okay. To make sure people understand the inference script again, just quickly calling it out. This is where you need to make the changes, right? Specify the model that you wish to use. These are the mandatory parts of the script. Okay, please make sure you are handling these, right? um, the base URL, I suggest you to stick to the router that takes care of everything. For the model name, you ensure what model you wish to use, but it has to be from within Hugging Space. Just take care of that. Okay, you can update your token while you're working in the local, and also the name of the image with which we build the Docker with. Okay. So these are the things that you need to change. Okay. Also getting some questions which are, I mean, not directly connected with the um, walkthrough that I gave, but there's a question on how many teams will be selected for round two. Do we sort of have that decided upon, or is that something that we are that's something that we have not yet um, revealed, and we wish to keep it? Any thoughts on that, team? Okay. All right. So basically, the idea is that there's like so whoever does well on the task can expect to follow through on the round two. And the idea is just build environments what you are being graded for. That's again available here on the page itself, right? So if you quickly take a look, I would also request all of you to treat this particular dashboard page as your as the holy grail for everything. Everything's mentioned over here, right? Just make sure you don't miss out anything from here. The grader part is mentioned here. Okay. If I talk about, let's say, the judgment part itself, right? So you can see over here that we have called out do not plagiarize, and make sure that the grader has some diversity in it. It should not be returning the same value or the same score every time. So these are the kind of things that you need to be aware of, right? Okay. There's also a question on how many submissions. Team, can you help me with this? Is it one, or do we allow multiple submissions? Okay, we are open with multiple submissions, guys. So just do as many submissions as you want, no problem. Okay. Sneha, that's a good question again. Both matter, and we have sort of created a. We do have over here like an example that you can refer to on the dashboard page. Okay, I'm specifically talking about your question here, which is that what matters, the idea or the everything works fine. It's a collection of both things, right? So you have to ensure that your inference should work fine. That is important, and also how creative your idea is. Both those things matter together. Let me quickly show it to you. Yeah, you can see over here, right, the criteria. So the utility of the idea, okay, and then uh, the quality of the grader that you've built, the how well have you designed the environment, and yeah, that's how the scoring is. Okay. Okay, so you can make submissions only up until 8th of April, guys. Please also keep the date in mind. That's super important, right? Yeah, you can see over here that deadline is 8th April. All right, so please don't forget that part. Okay. All right, and another thing, so if you are making multiple submissions and multiple of those are correct, the latest one is what we will be considering. Okay, so your most recent submission is going to be used for the evaluation, right? No, Kirti, I'm again specifying super important. Your submissions have to be real world. I took the gamified example simply to make sure you understand the concept well. That's the whole point. Your examples should not be gamified. They should touch upon a real world problem. That's very important. Okay. I've mentioned this a couple of times. Please make sure you're not missing that part. Okay. Again, refer to the page. Okay. This page is your final verdict for anything, right? Uh, I do also recommend, because you're getting all these questions, and I do understand the page is a bit deep, right? There are too many details on the page. So one of the things you can do is, again, utilize AI to the best. Just just copy it all, put it in a chatbot, put it in a chat GPT or whatever, and just ask questions whatever are coming to your mind, so that you get a clarity on what is okay and what is not okay, right? Please don't miss these important things out, right? It has to be a real world task. You can see over here, must simulate a real world task, not games or toys. Okay, Kirti, and anyone else who had a similar doubt, I hope this is now clear. Yes, for the examples, we have already shared a page with you. I'll probably share it one more time, but you can take a look at that through the Hugging Face page that Ben shared in the beginning itself, right? Let me see if I can share that page with you guys. That's a great place to, sort of rely on for real world examples. Okay. So let's see. I think you can refer to this page. Let me share another page with you. 1 second. Okay, I'll give you a walkthrough of some real world environments. Just allow me a minute. Let me open that for you guys. Okay, so this page is based on a previous hackathon that happened, right? And you can get a sense of the kind of things that people have built over here. Okay, so just refer to this page. We have provided this in the chat as well, team. If you could confirm once if we have provided this. Yeah, I can see it. It's already there in the chat, so you can refer to this one. Yeah, that's why we have shared this link with you guys already. So please just refer to it. It's there in the chat. It's there in the live link. So please refer to it. All right. So this is a project gallery. You can see the kind of submissions people have made over here, right? Let me see if I can show you some more examples. Let me check. Yeah. So this is the environment hub, right? So on the once you open this huggingface.openenv page, right? Once you land here, and over here you can see there's a link to OpenEnv environment hub. So just click, and this is where you can see a lot of different environments that people have built, right? But again, bear in mind, no plagiarism, right? Of course, if an environment exists, we know it does exist, right? So there's no point in sort of copy pasting it. So just make sure you are adding novelty to the ideas that you have on your mind. But this is where you can find a lot of different environments. Okay, cool. uh, Sir Hellstorm, I'm just calling this out one more time. Super important. Please don't miss this part. We have repeatedly been calling this out. Okay. You do not have to use the OpenAI API, right? We have called it out a couple of times. You can use the Hugging Face token itself along with the router, and this is part of the script that I've been the inference script. It's mentioned over there, and that's what you need to take care of. Like, let me give you a final walkthrough of this one last time. Okay, we sort of called this a couple of times, but make sure you don't miss this part out. You can see over here there's an API base URL. The whole idea is, if you look at the script, you'll see over here there's a router. So you don't need the OpenAI key. Your Hugging Face token will take care of hitting the OpenAI within the Hugging Face environment, right? So you don't have to worry about it. You do not have to create that key. Just the Hugging Face token is enough. That's why in the mandatory section it's mentioned, make sure you're using the Hugging Face token. Just create that. There are some free credits available within it. That should be good enough for you to be able to work, right? You don't need anything else. Please don't miss this part out, right? Okay. I hope this is now clear to everyone. All right. So, guys, I think I'll just take some time now to give some closing remarks, right? Firstly, I want to quickly mention that build teams, right? This is going to be way more fun and way easier if you're solving this with other people. You can already see, while the task itself, while OpenEnv simplifies the process of building these environments, but building the environment by itself does require some creativity at your end, right? It does require some experimentation, and things would be it'll be better. You'll be better off if you're in teams, right? So do form teams. It's going to be a learning opportunity for you, your friends, your colleagues. So uh, work with them towards building this. Okay, that's the first thing that I want to call out. And make sure you are following through the page. If required, use the dashboard landing page, copy the contents, push them into some chat GPT, Claude, whatever you like, and ask questions. The questions you were asking us, that page has the answer to all those questions essentially, right? So just uh, ask those questions over there. You'll get more clarity. Okay. One thing that kept coming up again and again, OpenAI key. You don't need that. We have called it out multiple times. Make sure you're using the Hugging Face token. That would take care of things. There's a router present in the inference script. It'll automatically hit whatever model you select. Okay, so that's pretty much it. And do enjoy while you're building this. Keep in mind the deadline, which is 8th of April. You won't be able to make submissions after that. Also, calling out, multiple submissions are allowed. We will consider your most recent accurate submission, right? So if you have made submissions that don't work and then later you make a submission that works, of course we'll consider that. So you don't have to worry about it. And any number of submissions are allowed. So also feel free to make a push as many times as you want. We are totally fine with it. So yeah, before we close, just a quick call out. I think Ben and team have done a fantastic work for enabling us to use OpenEnv and also be able to use Hugging Face Space to deploy all these environments. So kudos to that. Um, Thanks to Scalar for enabling this hackathon. That's again super duper important. And make sure you put in your submissions for for any sort of issues you face. You have the helper page over here. Just refer to it. Yeah, Scalar School of Technology is enabling this platform and hackathon, and any updates that are there, you will be receiving them. Hopefully, once you logged in, you would have already noticed you were getting all the updates over WhatsApp, over your email. So that's gonna continue to happen. We'll keep reminding you about the deadlines. So keep an eye out for that. And yeah, rest. Most of all, please have fun while working on this task. All the people who were there on this particular live are all present on LinkedIn. You can follow us on LinkedIn. You can follow Ben. You can follow me. And yeah, we would be looking forward to your submissions. All right, guys. That would be all from my side. Thank you. Thank you so much for all your time. And good luck to all of you.